There's my record button, and let me go to the sharing, and there it is. All right, so here we are, guys. So the first thing is, I'm going to keep mine on, once again, when you find a waterway size, keep it. So you go to stream, there's a lot of different sizes you can go to. I'm going to go down a little smaller so I get across a little faster. In fact, I'm going to go narrow. It'll take less time for me to get across. I like creeks. We'll go with the creek. First thing you got to do is find out how far that thing is across there. Okay? How far that thing is across there. So one way to find out, that's what number one is all about on your sheet, is to find out how far it is across. Time it. Okay? So it tells me my boat speed is 2.70, but I don't want the river messing anything up, so I'm going to turn my river down to 0. And I'm just going to time how long it takes to get across and calculate what my width is there. All right, launching, guys. Launch. Now, the key thing is the time will not stop when it hits the other side. I have to stop it. It'll just keep on running. And bam, nailed it, guys. 10.38 seconds. How in the world do I figure out how wide my river is? Well, let me do some annotating here. Let's do some red. So to find out how wide that is, I'm going to call that x equals average velocity times time. Well, I'm going straight across at 2.70 meters per second. It took 10.38 seconds to do that. So that is going to be how wide my river is. Okay? So 2.7 times 10.38, 28 meters across. Okay. So I'm going to keep that width for the entire lab. I'm not going to change that. All righty. So I've done it the first part. I got my width. Now I want to speed up my river. In fact, I might speed up my, I'm going to leave that where it is. Let me speed up my, okay. I'm on annotate. I got to stop my annotation here. Speed up my river. Oh, here's what I forgot to do. I forgot to hit click reset. My bad. So click and reset. Now I'm going to crank that river up to, let's say 2.29. Guys, I like easy math. I'm going to go to 3. All right. Not only that, I'm going to leave it at 3. All righty, guys. I want to know where that's going to land. And watch out for the logs, guys. That'll crash you. You got to watch out for that. I want to know where it's going to land over there. Well, to figure out where it's going to land, I need to know some things. Well, one thing I know, I'm going 2.7 and the river's going 3. So if I want to predict where I land, here's what I need to do. I need to do my vector diagrams. So here's one vector diagram. My velocity is going that way, and my boat speed is at 2.7 meters per second. However, I know my water is going to carry me downstream at 3. So that's even faster. So I'm going to go a little further down this way. So I think I'm going to land somewhere maybe over there. But I'm guessing right now. This is 3 meters per second. So to find my resultant vector, I do my Schwing, and then I got to do my Pythagorean theorem there. Well, I don't have to, but that would be my resultant velocity over there. Because that's what I want you to find, is what your resultant velocity is. So I do 2.7 squared plus 3 squared, 16.29, to the square root of 16.29, and that should be a 4. So 4 meters per second that way. And then I should also find my angle. I can use my tangent function. I can go the tangent of that angle equals my opposite, my 3 over my 2.7. So I do my inverse tangent, 3 divided by 2.7, 48 degrees, perfect. Okay, so my angle is 48 degrees, and that's what I have on my sheet, 48 degrees. But you'll notice this, the next question is, where does it actually land? Well, guys, that's what I'm doing. What's called the fastest way to do this is the law of similar triangles. Okay, unfortunately, I wrote right over where I wanted to write, so I'm going to make a new one. Okay, and look at that as a turtle. They don't bite. Okay, so this is a velocity vector diagram. I'm going to do a position vector diagram or displacement vector diagram. I already know my width is 28. And here's what I also know is that this is going to carry, because it's 28, I know it's going to carry it longer than 28 this way. But I'm not sure exactly how far right now. By the way, guys, here's a pop quiz. What do you think this angle is? If this is displacement, that's displacement downstream. This is the net displacement relative to the shore, somebody over here watching nearby. What do you suppose that angle is? Out loud and proud, guys, anybody know what that angle is? Same as this one. Because it's the same time to go this way as it is this way as it goes to this way. It's called similar triangles. So this is also a 48-degree angle. So if I want to find out how far downstream, let's call this change in x up here, downstream, all I have to do is set up a little proportion. It's called law of similar triangles. I can say 3 is to 2.7 meters per second is proportional to the change in position sideways as the change in position across the river, 28 meters. So I solve for x, I'm in meters. So really all I have to do is 3 times 28 divided by 2.7, shbang, 31. All right, guys, if I nail this, as soon as I push go, I should hit the 31 right there. Okay, let me try it out. Oh, I'm still annotating. All right, here it goes, guys. Cross your fingers. Let's hope old Olson didn't screw up. Look at this, guys. I got a line pretty good at this. Look at that. I'm not bad at that. And wait for it, and bam! I'm a teeny bit off. It's 31.2 or 3. I 31.1. That's pretty good, guys. That's not bad. So that's what you guys are doing today, okay? That's what you guys are doing today. Now, before I turn off the recording, let me clear all drawings. Okay, so so the next couple problems, you change the boat speed or the river speed and you do the same thing. The last problem is you got to get straight across. And get rid of that for a moment. And to do that, I know I have to point this way. I'm going to click over here. Oops, I'm not done here. I've got to unclick that. Click the reset. And when I click on this button, it moves my boat over there. Okay? That way I can better see what's coming and what's going this way, and I can better draw. You don't have to move it over, because theoretically I should move straight across. So my question is, how do I know what this launch angle should be? How do I know how far upstream to aim that so it goes straight across? Okay? Here comes Robert. All righty. So I don't know that right now, but here's what I know. My boat, okay, then here's going to be another issue you're going to have. I'm going to give you a heads up. If my boat speed is slower than the river, it ain't going to happen. I can't get straight. Even going straight upstream, I'm still going to carry downstream if I can go that. I have to be faster than the river. So I'm going to bump that up to 3, and I'm going to bump this down to something, maybe 1.5. There we go. Now I can actually know I can get across. Now to figure out exactly what angle to aim that at to do this, going back to annotate, I don't like that orange. Blue, dark blue. So I know I got to point the boat in some direction this way. I don't know the exact direction yet. And my boat speed is 3, and the water speed is 1.5. 1.5 meters per second, 3 meters per second. If I nail it, guys, if I nail that, that means the boat actually goes straight across. So all I have to do is find the angle. Pop quiz for you guys. What trig function do I need to solve for that angle theta? Are you guys there? Hello? What was that, Rob?
Sine.
That is the opposite over hypotenuse. So I go sine of theta equals the opposite 1.5 over my hypotenuse 3. Do my inverse sine on both sides of 0.5, because that's what 1.5 over that is. So if I do my inverse sine 0.5, bam, 30. Well, I should have known that. It's 30, of course. Okay, guys, I'm waiting at, oops, 30 degrees. So checking to see if I got this here. So my launch angle is, oops, unannotate. 90 is here, plus 30 is 120. All right, I'm ready to hit it, guys. You nervous? Look at that, guys, right along the green. Nailing it. I'm getting 100% on this lab so far, guys. And done. There it is. That's what the lab is all about, guys. Any questions? We stopped the recording.